So thanks everyone for joining me today. Like choosing between, I know there's multiple tracks and you guys choose to be here. This is the cool track, I assure you, for the next half an hour to 45 minutes. So hopefully I'll be able to maybe like teach you guys a few things that I learned from this side project that I built, and also entertain you guys along the way, sort of like edutainment. So the first of many jokes or punchlines will be this picture over here. This is one of my wedding photos. Very handsome guy. 5 years ago, 6 years ago already. Okay, but anyway, let's get started. Alright, so my name is Weiyuan. So I used to work for a ride-hailing company where my team is called the Chat and Voice team. So we work on messaging and calling features within the company. So imagine, in a ride-hailing app, you have people who need to call each other, like, passengers calling a driver, hey, where are you? Can you come to this place? So the building of these features, mainly we use vendors. Okay, imagine it like this, you guys might be asking, why do you need to use vendors? Can't I just call the guy's phone number and everything should work? And it turns out that there are more than, just being able to call someone's phone number. Imagine if you call someone, right, let's say as a passenger, you know the driver's number, you call them, what happens? There's a caller ID, right? They know your number. And then let's say you're a pretty lady, after the transaction ends and then the guy come and harass you, all sorts of safety concerns. So maybe we want to do a lot more than that by just, instead of just exposing people's numbers, but, giving them a bit of protection. Okay, so in the world of these calling services, when you're using these different vendors, there's also another thing called number masking. So using your own phone number, you call another phone number that we own, and our phone number calls the actual phone number. So you are not exposed to the knowledge of the driver's phone number, as well as the caller ID doesn't expose your number. But again, another problem, it's like paying for one call, you pay for the price of two. Imagine, right, you're calling one phone number, then the phone number that you own calls another phone number. So that's also expensive in some ways. So that got me thinking, we could use this anarchic like systems like the telco systems where you call all these phone numbers, right, using your own phone number. But what if you have a Wi-Fi connection or you have your own mobile data? What if you just use your internet connection to just talk to people? So I had an epiphany, how about we try doing that, explore that as an option. Maybe in the future as a side project I can put it in the company's in our mobile app in the future. Perhaps that's a way for us to save money as well. Okay, so yeah, building it ourselves. So I thought about it, I prepared all of the required frameworks, bring up the GitHub repositories, decided, okay, this is the tech stack I'll use Google Cloud, blah, blah, blah. I did all of the documentation reading, okay, and that was 1 year ago. So after spending so much time, and I realized it's a really, really hard problem to solve, but also because life took over and everything like that. So this year round, I decided to put all of my effort into, trying to make this project work. And some of you might have seen like a bit of a preview of that just now. Hopefully I'll be able to make it work later on. Okay. So before we actually go into the actual project itself, I want to talk about the problem statement. It's not just about showing you the final product, right? It's also about the process of how do we get there. So in my case, I'm trying to build a POC of this calling product using your own internet connection. Okay, so creating a calling function in a mobile application, that ride-hailing app, which is a mobile application. But okay, because it's a POC, right? I'm not a mobile engineer. I have DevOps, I have backend knowledge. I don't really have much mobile knowledge. So I decided, okay let's make it a bit simpler. Make the problem statement a bit simpler. Make it work for a web application first, like in a browser. If it works, then we'll migrate it to our mobile apps later on. Okay, and then breaking down the problem statement even more, we know that we need some form of front-end application as well as back-end application. Okay, front-end, very simple. You need that calling app, right, for the person to have access to. Back-end application, essentially you need to reach like some instructions from the back-end and then let the two users be able to communicate with each other. Okay, I'll talk about that a lot more later on. Okay, so, going back to, so if we focus on the front-end web application, yes, we know we need to build some form of calling functionality. And some of you who are here today, you all have seen from the title, yes, I'm talking about WebRTC. The definition of it is a free and open source project facilitating real-time connection. Okay, but going beyond that, there's actually more than that meets the eye, which is the peer-to-peer connection as well. So when you establish a WebRTC connection between two different users, one of the really great things is you don't actually have to facilitate that connection using some sort of backend server. The two different devices can actually talk to each other directly. Of course, for those who are more well-versed with WebRTC, you know that there's like a turn server connection, especially if let's say there's like a firewall settings that prevent these two devices from talking to each other. So there are more advanced configurations that I should have done. Like that's why I think maybe why the earlier demo, just now when I was trying out, it failed. But in my case, yeah, I think later on you all will get to see that peer-to-peer connection directly in the demo. Okay, then there's also a backend server. So just now I talked about that peer-to-peer connection, right? Now you might be asking me, if device A can talk to device B, why do we still need a backend server? Like that's nonsense, right? Like why am I wasting money over this? Okay, there are a few reasons why you need it. Think about it like this, like if I simplify the problem of, let's say, like using a regular phone number, you call another phone number, right? There's some sort of identity in place. Like your phone number is your identity. You call someone else, that number is their identity as well. The same thing goes for this VoIP, this WebRTC setup. When you are calling someone else, you have your identity and you need to know who's the person you're trying to call as well. So definitely we need some backend server. And also, WebRTC is not magic. It's not like your one single device knows every single device, like they can discover every single device in the world. You need some form of a backend server to perform data negotiation, to pass that information via the server, push it to the other device, and the other device will reciprocate and return that data back to the original device. So once you do that initial exchange, right, you'll be able to set up that peer-to-peer connection for this RTC call. Okay, so basically I've break down the entire problem statement to be as what you see in the screen over here. But in fact, this is not the whole thing. There's a lot more like to this problem statement itself, because we haven't even talked about the tools that we're going to use, what frameworks we're going to use, and what hosting tools we're going to be using here as well. Okay, so I want to bring you into the next chapter, which is the design of this system. So now that I've broken down the entire problem statement, okay, what are the actual tools I'm going to use to fix or to build this solution? Okay, so going back to the problem statement, I'm going to now transform this into the diagram to make it simple to understand, what are we going for. Okay, so we know that we have multiple users who, you can be using your laptops, you can be using your mobile phones, maybe even watch in the future as well. But you need to be able to load this front-end application, on the browser. And that browser should be able to talk to some backend service. Okay, again, we haven't talked about what this backend service, the code or whatever. Later on, we'll talk about it more, but essentially it should be something like this, high-level abstraction. Okay, let's first focus on the front-end application. So we know that we need to build some form of client, calling client over there using WebRTC. So if I were to supplant this back into this diagram over here, you can see that there's this client with that arrow pointing back towards itself. What this means is that in that front-end application, we not only need to cater for a caller logic, we also need to cater for a callee logic. Okay, because think about it, like your phone, right? You're trying to call someone else, you are the caller, but the other person's phone can also be a caller and also a callee at the same time. So you need to make sure in that same application, both of that logic, that switching of the statuses between caller and callee can take place. Okay, what else? If I go to my backend server, so just now we talked about these two different features we need to build up. Okay, the main focus I'll put here is the data negotiation functionality, because for identification, you can just treat it as like, you are calling HTTP APIs. I mean, that's simple backend API server stuff. But what about data negotiation functionality? There's some push action needed here. Push action here means that, let's say, okay, from device A call the backend server and pass the connection details. Backend server needs to find some way to talk to device B without device B actually calling the server in the first place. Okay, so the backend server needs to pass that connection details to device B, and device B needs to reciprocate, if they want to perform this calling functionality, and pass the connection details back to the backend, and backend will again push to the first device. Yeah. So there's some requirement for this like push flow, and there are two ways you can do this. If you're in a mobile device, one way I've learned from our vendors is they use push notifications, which apparently works. But the other more, I guess, popular way is to use WebSockets, which some of you might be familiar with as well. Okay, so if you're going to use WebSockets, you can see over here. So now in my backend server, I would need to have some sort of WebSocket server. On the front end, I didn't write it, but of course you need a front end WebSocket client as well. Okay. So now we have talked about, what exactly are we going to use, as part of the systems. How about the actual tools and infrastructure itself? For the front-end service and the back-end service, what tools are we going to use? Where are we going to host it? All right. So starting off with the front-end application first, I decided to go with the Next.js. Just asking who here has used Next.js before or know about what Next.js is. Okay. So for those who are not familiar with this, but okay, who haven't used Next.js but is familiar with React? Okay, not a lot of hands. But for those in the audience, right, if you're not familiar with this front-end framework, I would definitely recommend that you go and try it out, especially if you have already known how to use React. It's a very easy, I'll look at it as like a very easy web framework to get things started. You don't have to go through a lot of loops to set up let's say Angular. I mean, I know I'm wearing a Google shirt and everything, but Angular is one of the harder things to set up. I would say Next.js is a lot more simpler for this project as a POC. Okay, moving ahead from the front-end application, how about backend? Backend, there's multiple choices. You can go with Ruby on Rails, you can you use Go if you want, Python, some Python frameworks out there. Over here, I choose to use Node.js because it's very easy to just hack up. For POC, I find that it's a lot easier for me to just create a service very, very easily. I think Go, for example, there's a lot of hurdles you have to go through. So for Node, yeah, much more simple. Just get things started. In the future, if I want to migrate to using another language, I can do that as well. Okay, and hosting provider, I'll be very practical and say that, of course, you can use any cloud provider. I have free credit, so I just choose Google Cloud. But the products I talk about today, I'm not selling Google Cloud, by the way, I don't work for them. But definitely you can find similar products in other cloud providers to run the same application that I'm showing later on. Okay, so going back into our system diagram, you can see over there that I've added in the the boundary over here, which is Google Cloud Platform. Okay, and you can see that the front-end application and the back-end application needs to be existing within this environment. Okay, so let's start first with the front-end web application. I decided to replace that front-end web application, instead of that abstracted form, right? Now it's using cloud storage, okay, and of course running the Next.js web application. Okay, for those who are not familiar what cloud storage is in Google Cloud, right? But you're familiar with, let's say, the AWS equivalent. This is essentially S3. This is object storage. Think about it like storing files in there. Okay, big question that most people might have. Why object storage? If you're hosting a server, right, shouldn't it be on a VM or shouldn't it be a container somewhere? And my answer is this. Essentially, because I was thinking about running this as a static site, there's no need to have any server-side logic. I decided, okay, Next.js has an option where you can just generate a bunch of static files, put it in a bucket, and essentially you can just run the website directly from there. And there are a lot of benefits as well. You can definitely put it behind a CDN. You don't have to think about things like reliability, availability, scalability, because it's just serving files. As long as Google Cloud stays up, it shouldn't go down. Yeah. But of course, some of you might say, no server-side render logic. I'm a front-end engineer. I want this to render super, super fast. Like I said, yeah, I don't have any server-side logic, so this is essentially a non-issue. Okay, next, let's talk about our backend service. What are we going to do with our backend service? What are we going to use in Google Cloud for hosting this solution? Okay, what I decided to do is, since I'm using Node.js, I'm going to use it to build a Docker image and then push that Docker image into Google Cloud and use Cloud Run. Okay, so Cloud Run is a serverless tool that you can use in Google Cloud. And you don't have to worry about the nitty-gritty details of configuration. You can just bring it up. There's a lot of benefits that come along with this serverless tool as well, because all you need to do is just configure in the web console itself. You want to set the minimum instance, maximum instance. You can do all of those things. And best of all, you can actually scale to 0, which I'll show over here. Yeah, if you are looking at saving money like me, right, and you want to, in this case, most of the time I'm not using this service for the demo, right? You can essentially let it scale to 0. Oh yeah, on the top, what I'm mentioning over here is just that most serverless tools, I think over the last few years, doesn't really support WebSockets. In the recent years, actually Cloud Run started supporting WebSockets and putting in GA. So this is in the last 2 years? Yeah. So if you have been using serverless tools, but maybe you have been thinking about using WebSockets and maybe you have been discouraged in the past, just note that you can actually use stuff like Cloud Run for WebSockets at this point of time. Okay. One more con I just want to mention, just mentioning in terms of, for my knowledge in serverless, if you are looking at building, let's say, a bunch of microservices and you're thinking, okay, Weiyuan is talking about serverless here, it sounds like a good solution, can scale to 0, save money. One thing I like to warn is that if you're looking at a service with a lot of traffic and you're building a lot of services, the amount of, the cost can rack up over time. In terms of using serverless, because you are paying the platform provider money in terms of them managing the service for you. So at the point of time, if you're using a huge amount of microservices, like in my case, as a POC, this is a very simple, like, one front end, one backend service. In fact, it's just one single container in the backend. Front end is not even a service. So in my case, serverless makes sense. But if you're looking at scaling up a lot more in the future, 100 microservices, for example, you may not want to use serverless. You might want to go with something like a Kubernetes cluster instead. Okay, so at this point, we have reached this stage where I've showed you like all the ingredients that we can use to build this entire application. It's like a cooking show. I show you, I can put this salt, pepper, whatever, I put in an oven. Then I'll go to another oven, I'll take out, the completed dish, which is like, there's actually more stuff, of course, like, things that I didn't cover as well. For example, things like, putting in Redis, like for this memory store over here, is essentially a managed Redis that I'm using to put in my backend service, right? So to ensure that even if there's more than one Cloud Run service running, they can essentially persist that session across, like even if my browser is connecting to a different instance at all times. So there's actually a lot more, but if you're interested, you can look for me later. I can explain each one of this. But the essential ingredients, cloud storage, Cloud Run, those are the main things that's required here. Okay? Okay, so this is where the part I'm really worried about for the demo. Actually, I intended this to be a lot more fun, which is like, I ask someone for a volunteer, but because there's only one device that works, that I was supposed to like play this like, I'm not sure like for people who live in Singapore, asking for a volunteer, so I'm getting Harizan to help me over here. Okay, so give us like 1-2 minutes, we'll just set things up really quickly, and then I'll ask Harizan to move away from the rooms just to make sure this works. Okay, Harizan, can you come to the front? Yeah. Okay, give me a moment now.
Oh, you're not showing the screen,
Oh yeah, I need to share. Okay, so what I'm doing over here is essentially I'm identifying myself as Weiyuan first, so it's like kind of like a phone number. Okay, and I'm also using my phone to let Harizan like control as the other user. So I'm going to call Harizan John. Okay, so
just walk out.
Just walk out, like just outside the door. Don't do far, because my hotspot will die for this one. Okay, so while Harizan is walking out, so I'm just going to put his name over here. It's again like calling a phone number. Okay. Okay, so yeah. Hey Harizan, can you hear us?
Hello.
Yeah. So essentially, yeah, this is the demo of it. As you can see over here, in the URL itself, the front-end application is stored in cloud storage, and behind the scenes, there's actually WebSockets that allow us to negotiate the connection. So once that's done, that's how Harizan is able to now directly peer from my device or the mobile device he's holding directly to this iPad. So I'm guessing I can actually turn this around and so Harizan, do you see us? Oh. Yeah. Yeah. So not faking this is an actual video going on. Yeah. Okay. Okay, Harizan, you can come in now.
So sorry, the purpose of this app is that the user need not divulge his phone number. Is that the basis of?
That's correct.
Why? Okay.
Yeah. So I think you are getting to a very interesting point, which I'll talk about that in a moment, or you can ask during Q&A if I missed it. Give me a moment now. Okay, let's go back to this. Okay. Okay, so luckily it worked, but this was, okay, I'll just skip this. It's the exact same thing. Okay. So maybe to answer the one question, I think just now, you touched on a very interesting point, which is, I had to key in the names, right? There's some sort of identity there. And this one is just a POC indicating that as a user, I know the identity. But if you think about it as let's say the basis of a ride-hailing app, behind the scenes in the mobile phone itself, essentially you could just key in, let's say the user doesn't key in the ID itself, but rather you should have some form of business logic that indicate the IDs directly. And maybe only these IDs, right, can allow this call to happen only when the transaction is going on. Let's say there's an actual driver to passenger like booking going on, right, then you allow the call to connect. Because our backend server is still allowing the data negotiation of that connections. But if the booking is not there, right, then we just don't allow it to happen now. The backend service will just terminate it right away. Yeah. So the identity is still needed to identify the caller and the callee, but you can add in additional business logic to prevent the call from happening. Yeah. Okay, so what did I learn from this entire experience? I mean, beyond what I've showed you all so far for the front-end application as well as hosting Google Cloud. So I just want to say that I'm not an expert in WebRTC, but hopefully, you know, I can still show some of the learnings I have over here. But learning this was really tough. I think I was like stuck maybe like 1 to 2 days trying to figure out the flow on the front end, and it was so annoying but when it works, it works. When it doesn't work, it doesn't work, and there's no way to really like, you know, slowly figure it out. Yeah, but I know nowadays there's ChatGPT, and probably they can do it better than this. But I think a few months ago when I think I wasn't really actively using ChatGPT for this, someone at Stack Overflow actually gave this really good flow of how like how WebRTC is supposed to work. You know, the negotiation all the way down to actually like making the phone call for the ICE candidate pairs to go through. Yep. So just to make it even more simpler, like of course I'll share this after this session itself. If you're familiar with UML sequence diagrams, essentially this is what it is. Like you have a first user and a second user. At different times before the call itself, they need to initialize their connection with the backend. Okay, and then after this is done, when you're exchanging the WebRTC connection details, then of course there's a data negotiation that takes place, because first device will talk to a backend first and pass the information. And then as I said, right, there's the push logic over there, where from a backend service, they'll push that information connection logic to the second person's device. And then second person's device, if they accept the connection, they will take their own connection details and pass it back to the backend, which will do the same thing for the first device. So essentially allowing this entire process, right, to happen both for the first device and second device. So once that's done, essentially you are just able to make that call from there. Like the first user can just do that peer-to-peer connection directly. But of course, if there is, you know, let's say like firewall-based issues, definitely you can put your own turn servers in as well. So, I put a joke in here, but no one realized there's a joke here. Anyone recognize these songs here? This is like maybe like 10 years ago already. Yeah. Any guess? Anyone wants to take a guess like what these two songs are? Oh, yes, the second one is Payphone. Yeah. How about the other one? Yes. Call Me Maybe. Yeah. Okay. Anyway, I guess it's not that entertaining, but but other than that, yeah. So if you're interested in learning more about WebRTC, right, actually a big recommendation for me, like I'm not expert at it, I'm still learning, but there's a lot of WebRTC samples out there. This is like hosted on the web. You can go and try it on your own device. The best thing is that all of this is linked to a GitHub repo, again by someone else. This is all open source. So you can go and use that and try and use it to build your own application, which I did in my case as well. Okay, and of course there's more improvements to be done. Like you guys are a very kind audience. Like no one actually went to the website that I showed just now, right? In fact, someone could have just went in and actually like just break my entire demo just now. But the thing is, yeah, for the future, I'm going to spend the next few weeks actually building IAP, which is Identity Access Proxy, so to prevent random people in the audience from hijacking the demo. But thanks for not doing that. Yeah, I didn't ask for it, but no one did that, so that's a good thing. And yeah, that's the end of my sharing over here. Hope you guys picked up something from it. Thanks. Yeah. If you want to connect, yeah, you can find me on LinkedIn as well. If you all have any questions, I'll be happy to take it.
Yeah, because the demo gods are not calling on you today, I realized that you were mentioning something about hotspot, right? So this is actually connected via LAN. So peer-to-peer via LAN is of course always going to be easy, right?
Yes.
I face a similar problem when trying to do a peer-to-peer file transfer application while using NUS network, which is way more complicated than any simple LAN. So how do you overcome piercing through all that firewall nonsense?
I did not overcome it because I just discovered it today. But yeah, I mean, that's a new learning for me as well. I tested this like over a weekend where I hacked it up, and I failed to realize, yeah, actually everything I use on my home Wi-Fi. So I thought it would work. Even this morning I tested it, it worked. Then I realized today that, okay, this is the first time I'm testing it outside. I learned from it, like apparently this works, as you said, yes, over LAN. So I need to go and fix it. Probably put in the turn server later on. Like for WebRTC, the turn server will be the one that will help you out. Probably there's like some firewall, like some network issue that's preventing these two devices from connecting directly. I am not very good at that, so I'll probably say please go search online. Yeah.
So what are some of the use cases that you think, I mean, other than ride-hailing, you have, what other stuff can use something like this? I mean, to me, giving away the telephone number, no big deal really, because nobody wants my telephone number. Yeah. I'm not a pretty girl, is it?
I guess it's very much a selective problem lah. In the ride-hailing industry itself, there is that, it's kind of like when shit hits the fan, it really hits the fan. When people are really impacted, they are really impacted. But I also acknowledge that, yes, to be honest, like even for myself, actually, I also don't care. Like, I mean, if I leak my number, I mean, if someone wants to harass me, I think maybe I'll be a bit happy. But but the thing is, there are people who, I mean, at my workplace where I've seen people being harassed, and it is a needed measure there. And also it's needed because it's much more cheaper than number masking. Like having to own an actual phone number, having to dial the actual, like from the telco, other people's telco to our telco and then to another telco, right? Essentially that's a lot more costly. Besides ride-hailing, I think the other place where I've seen my friends use this before, telemedicine, like rather than using Meet or Zoom, like, I mean, again, another way of, like, if you have your own application that you want to talk to people directly, rather than using like the public solutions like Zoom or Google Meet and stuff like that. But if you're a startup, of course, I would just say, like, just use those free solutions. It's only when you're scaling at a really high level. I think that's where, like, for example, for Zoom, it's going to be very expensive. Or when you're using like Google Meet, like I think the enterprise solutions are also very expensive lah. So at large scales, I think this makes sense. At a small scale, probably like just using a free Zoom, like I think, or Google Meet, I think there's a limit of like, Zoom, I think there's a limit of like 45 minutes for the free one. So I think usually for small companies, probably they won't mind it too much lah until they go to it at the big scale. Yeah.